ABCD is a trapezium in which AB is parallel to DC and AD is equal to BC. Show that angle A is equal to angle B, angle C is equal to angle D, right? And remaining things, that congruency and all, we can prove that. So they are giving a hint: extend AB and draw a line through C parallel to AD intersecting AB at E. Okay, that's your hint. So I would like you guys to complete the diagram and write given and everything. So in this case, we need to draw the diagram. So your answer starts over here. Okay, so let's go about doing this. So we have to extend this so that we have a parallel line. Okay, something like this. So this should be parallel to this, right? So that they are intersecting at E. You can name it anything whatever you guys want. It's just for the sake of convenience. Okay, so we have done. So this is parallel to this. That's it, right? Huh. Now, so what else can we do? Well, let's write the given before we start thinking about anything else. Given ABCD is a trapezium with AB being parallel to CD and AD being parallel to, sorry, not parallel, equal to BC. Okay. So then what else? That's it, right? Then we need to prove four things actually. Angle A is equal to angle B, angle C is equal to angle D, triangle ABC is congruent to triangle BAD, and diagonal AC is equal to diagonal BD. So we have done a construction. It's a hint, but still it's a construction. Extending AB and drawing a line via C parallel to AD intersecting AB reduced at E. So a very long thing. Okay, so yeah. Now my question to you guys is, how do we go about proving this? Okay, first thing first, I'll give you guys a clue. We have this to be parallel to this and we have drawn this to be parallel to that. So what can you tell? Consider AECD as opposite sides are parallel. We can conclude that it's a parallelogram. It's a parallelogram. So what can you tell from this? So since we have this to be a parallelogram, we can tell that AD is equal to EC. That's one thing which we can tell. So this implies AD is equal to EC. So these two sides are equal. Okay, so I don't know how will that help now. So let's think over how do we make use of this. So if this is x, this also will be x. Then we have to prove this as x, so this as x. If you prove that, we are done, and the rest of it is quite simple. So if this is x, this is x, we have to prove that this to be x. So how to do this? Think. Okay, I'll give you guys a clue. Let's begin with thinking about this being parallel to this. This acts like a transverse line. Okay, so if I prove that this is x, so this will be x. So how to prove that this is x? So for that we need to go to triangle, yes, BEC. Okay, so let me show you guys what I'm talking about. So as of now we have this and angle ADC is equal to angle AEC. So we can tell, let angle ADC, this is opposite angles of parallelogram, this is opposite side of parallelogram. Okay, so these are all the conclusions. So let us call them as x. It's easy to handle things in the future. Now this two are x. So what next? In triangle BCE, we have CB is equal to CE. Why is that? Reason, CB is equal to AD, right? CB is equal to AD and AD is equal to CE. Okay, so because of this reason, these two sides are equal. So what can we do with this? So then we can tell that, therefore, angle CBE is equal to angle CEB, which is equal to x. So this I'm calling it as x. So why? How is that? Because they are opposite angles to equal sides in a triangle. This is the reason. Now, with this as x, we can call this as also x. Why? EBC is equal to DCB. So I'll show you why. We have a line and another line, and this is your transversal line. So this is x. This also should be x because these two are parallel. Does it make sense? Okay, so we just have to name this and things will be clear to you guys. So this is your A and this is your B, C and D. And this is my E, I guess, right? Yes. So we can tell EBC is equal to angle BCD, which is equal to x. Why? Alternative interior angles, as AE is parallel to DC. Okay, so next thing is what? Yeah, we have AD, this is x and this is x, so we had proved it. Therefore, angle ADC, which is equal to angle BCD, which is equal to x. So one part is proved. Next, moving on to proving that AD, AB and ABC are equal. Okay, so basically these two. Why are they equal? Again, it has to do something with the parallel lines. Can you think of it? Right, we can tell angle DAB plus angle ADC is equal to 180 degree, because AB is parallel to DC and these two angles are co-interior angles. Okay, so angle D and angle A are co-interior angles. So angle DAB plus X is equal to 180 degree. Therefore, angle DAB is equal to 180 degree minus X. Okay, what else? Similarly, we have angle ABC, right? Over here, you can see over here itself, plus angle BCD, or this is equal to 180 degree, same reason. Therefore, okay, we need to write angle ABC plus X is equal to 180 degree. Therefore, angle ABC is equal to 180 degree minus X, right? This is 180 minus X. This is 180 minus X. So from this two expression, I'll call it as A and B. So from A and B, we have angle ABC is equal to angle TAB, right? Okay, we have proved that many things. And next thing is we have to prove the triangle ABC. So we need to join this is congruent to BAD. Okay. So clearly they are congruent, same base, two angles are equal and these two sides are equal. So we have consider triangle ABC and triangle BAD. Okay. So we have AB, that is common. Then we have angle ABC, which is equal to angle BAD, right? They are equal, we already proved that. And we have AD is equal to BC, this also we have proved. Thus by SAS congruency, triangle ABC is congruent to triangle BAD, right? So that is done. And diagonal AC is equal to BD, that is simple. Since we have proved this by CPCT, BD is equal to AC, and we are done. Remember, always drawing an extra thing whenever you're confused will always help.